Problem number 17. Here we have the differential equation 5 times the second derivative of y with respect to x equals to 1 plus the first derivative of y with respect to x squared whole raised to the power of 3 over 2. Here we have a radical 3 over 2 on the right hand side, so we need to get rid of it. So we can do that by squaring both sides, and that should give us 25 times second derivative of y with respect to x squared equals to 1 plus first derivative of y with respect to x squared whole raised to the power of 3. Looking at the differential equation, now we see that the highest order differential coefficient present as the second derivative of y with respect to x, so the order is going to be equals to 2, and since its power is 2, the degree will be equals to 2, and this is going to be a non-linear differential equation. Problem number 18. Y is equals to x times derivative of y with respect to x plus a times square root of 1 plus first derivative of y with respect to x squared. We can rewrite the given differential equation as y minus x times derivative of y with respect to x is equals to a multiplied to square root of 1 plus dy over dx squared. Squaring both sides, that's going to give us y squared minus 2xy times dy over dx plus x squared times dy over dx squared equals to a squared times derivative of y with respect to x squared. When we rearrange the terms, we're finally going to get x squared minus a squared times dy over dx squared minus 2xy dy over dx plus y squared minus a squared is equals to 0. We can see that the highest order differential coefficient present in this equation is the first derivative of y with respect to x, so the order is going to be equals to 1, and since its power is 2, the degree is going to be equals to 2, and this is going to be a non-linear differential equation because if we look at the second term, the coefficient is negative 2xy, which is clearly not a function of x only but a function of x as well as y. It should have been a function of x for it to be a linear differential equation. Hence, the given differential equation is non-linear in nature. Number 19. Y is equals to first derivative of y with respect to x times x plus square root of a squared times first derivative of y with respect to x squared plus b squared. Proceeding as before, we have to get rid of the square root term, so we're going to rewrite it as y minus x times dy over dx equals to square root of a squared times dy over dx squared plus b squared, and square both sides, and that is going to give us y minus x times dy over dx whole squared is equals to a squared times dy over dx squared plus b squared. This is a first order differential equation because the highest order derivative present here is dy over dx, and since its power is 2, so the degree is going to be equals to 2. And this is a nonlinear differential equation. That is because if we expand the term on the right hand side, this is a nonlinear differential equation because if we expand the term on the left hand side, we're going to get a term negative 2xy times dy over dx. That multiplication with y is what makes it a nonlinear differential equation. Problem number 20. Second derivative of y with respect to x plus 3 times the first derivative of y with respect to x squared equals x squared times log of second derivative of y with respect to x. The highest order differential that is present in the differential coefficient is 2. So the order is going to be equals to 2, and the degree here is going to be undefined. The reason behind is that the argument of the logarithmic function is the differential d squared y over dx squared. So here we cannot define the degree, but nonetheless its linearity is always going to be a non-linear differential equation.